Okay, so here we go. So let's do the process. It's all written down here, so you just get to watch and listen and not take notes. So here is my polynomial over my polynomial. I want to first factor the denominator. So it's got an x cubed, which usually you can't factor, but notice there's an x between all of them. So if I factor an x out of all of them, then I'm left with a quadratic that will factor these two. So I have three distinct linear factors. So I first break up the fractions. So it is necessary that you write this first, right? That you write this polynomial over the polynomial, all nice and factored, equal to, and I'm going to write the distinct factors, a over x plus b over the 2x minus 1 plus the c over the x plus 2. So you need to have this side of the equation. So many times people just write this side down, but that doesn't work that way. You need to have this written down. Okay, so now our job is to find out what the a, b, and the c are. So let me erase here for a second so that I can show you what I'm going to do. So my next step is to multiply both sides of the equation by the denominator, by this denominator from the left-hand side. So if I multiply both sides by x times 2x minus 1 times x plus 2, and let me write it here, because this is, again, just like in those surface area and arc length problems, it's the first step that people make the mistake on, and then everything else kind of falls apart. So be really careful. So this is crucial. So when I multiply this times this fraction, the denominators cancel, so I'm just left with this, right? Okay, so now I'm going to distribute this to these three terms, and I'm going to cancel as I go. So if I'm multiplying this times this term, the x's will cancel. Don't put crosses through them or x them out because you need it for the next term. So the x's cancel. So what am I left with? The letter a times this times this. The letter a times this times this. Then I'm going to multiply this times here. So I get the letter b, the 2x minus 1s will cancel, so I'll be left with an x and an x plus 2, an x and an x plus 2. Then multiplying this times here, the x plus 2's will cancel, so I'll be left with the letter c times x times 2x minus 1. Okay. So I do not want you to multiply this all out. I want you to be wise, be smart. I know you're smart, so I want you to think about what number could I put in for x that could zero something out here. So I'm looking at this here, and I'm thinking x equals 0, letting x equal 0 will zero these two terms out, and then I can solve for the a. So you don't just choose random numbers, you choose numbers that will zero a couple of things out and not the other. So choosing x equals 0 means you put x equals 0 in for those two terms, so those are gone. So the left-hand side just gives me -1. So I'm putting x equals 0, so those two terms are gone. So if I put x equals 0 here, I get a times -1. Put x equals 0 here, I get times 2. So this is the equation I get to use to solve for a, so I get a is 1/2. Okay, so then I go back to the drawing board and I look for the next wise number to plug in. Again, not random numbers, but can you see that x equal -2 would be a wise number because x equal -2 will make these two terms 0, and I'll just be left with this and this. Okay, so let's plug in x equal -2. So if I plug in x equal -2 here, I get 4 minus 1. So it still is -1 on this left-hand side. Plug in x equal -2, that's 0, that's 0. So I'm going to have this c times -2, and put -2 in here. So I'll get a -4 minus a 1, so it's a -5. So solving this, I get c is -1/10. All right, so the last wise number to plug in will be what makes this 0. And what makes this 0, right? What makes 2x minus 1 0 will be x equal 1/2. So that's what this is. And I'm just going to skip the work, but you just plug in x equal 1/2, and I ended up getting b is 1/5. Okay, so this here, let me get my erase here so I can see it neatly. I have to be able to see this initial step. So that's why I didn't want to put x's through it, because now I want to put the a in. So I've got the a is 1/2. I want to put the b in. So the b is 1/5. And I want to put the c in, and the c is negative 1/10. So put all of those in, and I put them out in the front, right? And so this one here is an easy ln, right? So I see this as 1/2 ln of absolute value of x. These two here need u substitution. So be careful. Remember, you want to let u equal the denominator. So you want to let u equal 2x plus 1. So du is 2 dx. So I get a 1/2 in the front, 1 over u du. So that gives me a 1/10 ln of u. So 1/10 ln of 2x minus 1. So putting it all together, and this one here again, it just needs an easy u substitution of u equal x plus 2. So I'd get negative 1/10, 1 over u du. So that would give me a negative 1/10 ln of x plus 2 plus a c. So put all those three things together. Okay, so you can see we're going to have quite a few little ln's. So I'm going to suggest you get this memorized. So if I have ax plus b, and the easy u substitution will give me the 1 over a. So add this to your La Jolla theorem so that I can go right from here to my answer.